Picture this. You wake up one morning, but something feels off. The sky is a shade of purple you've never seen before. Your reflection in the mirror winks at you, except you didn't. And when you step outside, the city you've lived in your whole life is suddenly unrecognizable. What if I told you this isn't science fiction? What if our universe isn't the only one out there? The multiverse theory isn't just a wild idea from comic books or blockbuster movies. It's a serious scientific concept that could rewrite everything we know about reality. Imagine a cosmic tapestry where infinite universes exist side by side, each with its own laws of physics, its own versions of you, its own alternate histories. Somewhere out there, dinosaurs might still rule the Earth. Another version of you could be a famous inventor, or maybe even an intergalactic explorer. This isn't just about parallel worlds, it's about the very fabric of existence. From quantum mechanics to cutting-edge tech, the multiverse theory isn't just reshaping science, it's changing how we think about our place in the cosmos. And here's the kicker. If it's real, it could mean that every choice you've ever made has spun off another universe where you took a different path. So buckle up, because we're about to dive into one of the most mind-bending ideas in physics, and by the end of this journey, you might never look at reality the same way again. Now, let's break it down to the fundamentals. The multiverse theory isn't about one single universe, it's the idea that our cosmos might be just one tiny piece of an unimaginably vast puzzle. Think of it like a bubble in a cosmic bubble bath, where each bubble is its own self-contained universe, floating alongside countless others. Unlike the observable universe, the part we can see and study, the multiverse suggests there are realms beyond our reach, each with its own unique rules. Maybe in one universe, gravity is twice as strong, making every step feel like walking through molasses. In another, time might flow backward, or light could move so slowly that shadows outrun you. And here's where it gets personal. Some of these universes might host alternate versions of you, living lives shaped by different choices. Mr. Train in this world. In another, you caught it, and who knows how that tiny change rippled out. This isn't just science spinning wild tales. The multiverse theory emerges from real physics like quantum mechanics and cosmic inflation, offering answers to questions we've barely begun to ask. So while we're stuck in our little bubble for now, the possibility of infinite others out there, that's a game changer. But where did this mind-bending idea even come from? Believe it or not, the seeds of the multiverse were planted long before modern physics. Ancient Hindu texts described countless universes floating like bubbles in an endless ocean, each with its own gods and stories. Fast forward to ancient Greece, where philosophers like Democritus imagined infinite worlds scattered across the void. These early thinkers didn't have telescopes or quantum equations, but they grasped something profound, that reality might be far bigger than what we see. The real game changer came in the 1950s with a young physicist named Hugh Everett. While most scientists were focused on our single universe, Everett dared to ask, what if every possible outcome actually happens? His many worlds interpretation turned quantum mechanics on its head. Imagine flipping a coin. In our world, it lands heads, but Everett said there's another world where it lands tails, and both are equally real. Suddenly, every choice, every random event could spawn new branches of reality. Critics called it science fiction, but today, his radical idea fuels everything from quantum computing to blockbuster movies. What's fascinating is how these old philosophies and cutting-edge science point to the same wild possibility, that our universe might just be one page in an infinite cosmic library. Next time you wonder what if, remember somewhere out there, another version of you might be living that very answer. Now let's take a closer look at how the strange rules of quantum mechanics might actually create these parallel realities. Picture this, you're standing in front of two doors and you have to choose one. In our everyday experience, you'd pick either door A or door B, and that's that. But in the quantum world, things aren't so straightforward. According to quantum superposition, a particle can exist in multiple states at once, like being both here and there simultaneously until it's observed. That's where the famous Schrödinger's cat thought experiment comes in. Imagine a cat in a box with a device that might or might not release poison based on a quantum event. Until you open the box, the cat is, in a sense, both alive and dead at the same time. It's only when you look inside that the possibilities collapse into one outcome. Hugh Everett took this idea even further. He suggested that instead of collapsing into a single reality, every possible outcome actually happens, just in different branches of the multiverse. So if you chose door A in this universe, there's another version of you who chose door B, and both realities are equally real. This means every tiny quantum event, every particle spin, every random fluctuation could be spawning new timelines constantly. It's not just about big life choices. Even the tiniest interactions could ripple out into entirely new universes. Think of it like a tree with endless branches. Each decision, each random event, splits the path again and again, creating a sprawling web of possibilities. Some scientists argue this could explain why quantum mechanics seems so unpredictable, because all outcomes are happening somewhere. Of course, this raises wild questions. If every possibility exists, does that mean there's a universe where you're a rock star, or one where dinosaurs never went extinct? The math suggests it's possible, but proving it is another story. What's incredible is that this isn't just philosophy. It's a framework some researchers use today, especially in fields like quantum computing, where particles harness superposition to perform calculations faster than any traditional computer. So the next time you face a tough choice, remember, in some other universe, you might have already taken the other path. Now, let's zoom out from quantum mechanics and look at the bigger picture literally. Cosmic inflation theory, proposed by physicist Alan Guth, gives us another compelling piece of the multiverse puzzle. Imagine blowing up a balloon covered in tiny bubbles. As the balloon expands, those bubbles grow and multiply, each one its own separate space. That's kind of how cosmic inflation works, but on a universe-sized scale. According to this theory, right after the Big Bang, our universe went through an incredibly rapid expansion, faster than the speed of light, stretching space-time like taffy. But here's the twist: inflation might not have stopped everywhere at once. Some regions of space could have kept expanding while others settled down, forming what we now see as separate bubble universes. Each of these bubbles could have its own unique physics constants and even laws of nature. Our universe, just one bubble in an endless cosmic froth. This idea helps explain some of the mysteries of our universe, like why it looks so uniform in every direction. Inflation would have smoothed everything out in those early moments. But it also opens the door to something even wilder. If inflation is eternal, as some theories suggest, then new bubble universes could be popping into existence all the time, forever. That means the multiverse isn't just a static collection of parallel worlds, it's a growing, bubbling ocean of realities. And here's where it gets really mind-bending. If other bubble universes exist, they might be completely unreachable, hidden beyond the horizon of our observable universe. We could never see or interact with them, but the math suggests they're out there. Some scientists even speculate that collisions between these bubbles might leave faint traces in the cosmic microwave background, the afterglow of the Big Bang, giving us a possible way to detect other universes indirectly. So, while quantum mechanics gives us branching timelines, cosmic inflation paints a picture of an endlessly sprouting multiverse, where every bubble is a self-contained cosmos with its own story. It's a humbling thought. Our entire universe might just be one tiny speck in an infinite foam of possibilities. But what if the multiverse isn't just about bubbles or branching timelines? Let's take a deeper dive into one of the most mind-stretching ideas in modern physics: string theory. This framework suggests that the building blocks of reality aren't particles but tiny, vibrating strings. And here's where it gets wild. These strings don't just dance in the 3 dimensions we know plus time. They require extra dimensions somewhere between 10 and 11 in total to make the math work. So where are these hidden dimensions? Think of them like the curled-up edges of a carpet. From a distance, a carpet looks flat and one-dimensional, but up close you see the tiny fibers woven into it. Similarly, these extra dimensions could be compactified, folded up so tightly that we'd never notice them in everyday life. But here's the kicker. The way those dimensions curl and twist could determine the very laws of physics in a given universe. Picture this. Each unique configuration of these hidden dimensions might create a completely different universe with its own rules. One twist could give you a world where gravity is stronger or where atoms behave differently. That means string theory doesn't just hint at a multiverse. It suggests a landscape of universes, each with its own unique physics, like an infinite cosmic menu of possibilities. Now you might wonder, if we can't see these extra dimensions, how do we know they're real? That's the challenge. String theory is still largely theoretical, but it's one of the few frameworks that could unite quantum mechanics and gravity, a holy grail of physics. Some scientists hope that high-energy experiments like those in particle colliders might uncover clues like traces of higher dimensional gravity leaking into our world. And here's the real brain twister. If string theory is correct, our universe's particular set of laws, the ones that let stars, planets, and life exist, might just be a lucky roll of the cosmic dice. In another universe with different curled-up dimensions, reality could be utterly unrecognizable. So next time you look up at the night sky, remember, what we see might be just one page in an endless library of universes, each written in its own unique physics. Now let's shift gears and talk numbers, because the multiverse isn't just a wild idea. It might actually solve one of physics' biggest puzzles. Think about the constants that govern our universe, like the strength of gravity or the charge of an electron. These numbers aren't random, they're precisely tuned to allow stars, planets, and life to exist. Change them even slightly, and the universe as we know it falls apart. This is called the fine-tuning problem, and it's baffled scientists for decades. Why do these constants have such perfect, life-friendly values? One compelling answer is the multiverse. If there are countless universes, each with different physical laws, then it's no surprise we find ourselves in one where everything just works. It's like winning the cosmic lottery, except instead of money, the prize is a universe where atoms can form, chemistry happens, and life emerges. Take the cosmological constant, which controls how fast the universe expands. If it were slightly larger, matter would fly apart too quickly for galaxies to form. Slightly smaller, and the universe would collapse in on itself. Yet somehow it's perfectly balanced. In a multiverse, this isn't a miracle, it's statistics. With infinite universes, some had to get the numbers right. Critics argue this is just a fancy way of saying we got lucky, but supporters counter that the multiverse offers the simplest explanation. After all, if you shuffle a deck of cards enough times, you'll eventually get a royal flush. Our universe might be that rare, perfect hand in a sea of cosmic possibilities. So next time you marvel at the night sky, remember, the math behind our existence might not be magic, just one possibility in a vast, shimmering tapestry of realities. And who knows, somewhere out there, another version of you might be pondering the same thing in a universe where the rules are just a little bit different. Now, let's take a step into something even more mind-bending. What if our universe isn't just one of many, but a simulation? This is where the multiverse theory meets cutting-edge tech, thanks to philosopher Nick Bostrom's simulation hypothesis. Imagine an advanced civilization so powerful they could create hyper-realistic digital worlds, complete with conscious beings who think and feel just like us. If that's possible, then our universe might not be a cosmic accident at all. It could be someone else's experiment. Think about how far video games have come in just a few decades. Now picture a civilization thousands or millions of years ahead of us with technology we can't even fathom. They might be running countless simulations, each with its own laws of physics, history, and even versions of you. In that scenario, the odds that we're in the real universe start to look pretty slim. Bostrom argues that if even one advanced civilization ever runs ancestor simulations recreating their past in digital form, then statistically, simulated minds would vastly outnumber biological ones. So, are we the originals or just lines of code in someone else's universe generator? This idea isn't just sci-fi, it's got some serious scientific backing. Tech visionaries like Elon Musk have pointed out that if progress in virtual reality continues, eventually simulations would be indistinguishable from reality. And if that's true, the chance we're living in base reality is, well, 1 in billions. But here's the twist: if we're in a simulation, could we ever prove it? Some physicists suggest looking for glitches in the fabric of reality, tiny errors in the laws of physics that might reveal we're in a programmed construct. Others propose that if the universe is digital, it might have a pixelated structure at the smallest scales, something future experiments could detect. Of course, not everyone's convinced. Critics say the simulation hypothesis is just modern-day solipsism, a fancy way of questioning whether anything's real. But whether you buy it or not, the idea forces us to ask bigger questions. What does real even mean? And if we are living in a simulation, does that make our lives any less meaningful? One thing's for sure: if the multiverse is real and simulations are possible, then reality might be stranger than anything we've dreamed up. And somewhere out there, another version of this video might be playing on a screen in a universe where the rules are written in ones and zeros. Now let's shift gears and see how these mind-bending ideas have leaped from the lab to the big screen. The multiverse isn't just for physicists, it's become a playground for storytellers, and pop culture has run wild with it. Take the Oscar-winning film Everything Everywhere All at Once, where a laundromat owner discovers her countless alternate selves across infinite realities. It's not just a wild ride, it's a brilliant way to visualize how tiny choices could spin off entirely different lives. Then there's Rick and Morty, the animated series that turns multiverse theory into a dark comedy. Rick's portal gun lets him hop between dimensions, but the show doesn't shy away from the chaos that comes with infinite possibilities. One episode even features a reality where people turn into sentient pickles, because in a multiverse, anything goes. Video games have jumped in too. BioShock Infinite drops players into a floating city where alternate timelines collide, forcing you to confront the consequences of branching decisions. And Marvel's Spider-Man games and movies, they've made multiverse a household word, with Peter Parker meeting versions of himself from other dimensions. What's fascinating is how these stories shape our understanding of real science. When Doctor Who talks about parallel worlds or the Flash races through timelines, they're introducing millions to concepts that physicists debate in journals. Sure, they take creative liberties. No one's claiming a universe where pizza rules the planet is scientifically accurate, but they spark curiosity. Suddenly, abstract ideas like quantum branching or cosmic inflation feel tangible, even fun. And let's not forget the classics. Sliding Doors explored how a single missed train could split a life into two paths, while The Matrix, though more about simulation, got us questioning reality itself. These stories stick because they tap into a universal question. What if you made a different choice? What if history unfolded another way? That's the power of pop culture. It turns equations into emotions, theories into thrills. Whether it's a blockbuster or an indie game, these creative takes don't just entertain. They invite us to imagine the unimaginable, one parallel universe at a time. But what happens when we throw time travel into the mix? Suddenly, the multiverse isn't just about parallel worlds, it's about rewriting history itself. Think of Back to the Future, where Marty McFly's actions in the past create a ripple effect, altering his present. That's the idea of branching timelines in action. Every change, no matter how small, could spawn a new reality, leaving the original timeline untouched. This solves one of time travel's biggest headaches, the grandfather paradox. You know, the classic question, what if you went back and accidentally prevented your own birth? In a single universe model, it's a logical nightmare. But with the multiverse, you're not erasing your existence, you're just creating a new timeline where you never existed, while your original reality chugs along unchanged. Sci-fi loves playing with this. Avengers in-game showed the Avengers hopping through time, but their meddling didn't undo their present, it created splinter realities. Even Doctor Who dances around this, with the Doctor insisting some events are fixed points, while others can bend. The takeaway, time travel might not rewrite history, it could just add another branch to the cosmic tree. And alternate histories take it further. What if the Nazis won World War II? What if dinosaurs never went extinct? These aren't just fun thought experiments, they're glimpses into how fragile our reality might be. The multiverse suggests every what if isn't just hypothetical, it might be real somewhere in some other universe. So next time you watch a time travel story, ask yourself, are they changing history or just discovering another thread in the vast tapestry of the multiverse? The answer might just bend your mind. Now, let's take a detour into one of the most mind-bending ideas in physics. What if black holes aren't just cosmic vacuum cleaners, but secret doorways to other universes? The idea isn't as far-fetched as it sounds. Some theories suggest that the crushing gravity of a black hole's singularity might not be a dead end, but a tunnel, a wormhole connecting our universe to another. Think of it like this: a black hole's singularity is a point where space and time break down, where the rules of physics as we know them stop making sense. But what if that breakdown isn't destruction but a gateway? Recent research on singularity behavior hints that under extreme conditions, space-time could twist into a bridge, linking two distant points or even two separate universes. Then there's Hawking radiation, the faint glow predicted by Stephen Hawking that black holes emit as they slowly evaporate. Some scientists speculate this radiation might carry traces of information from whatever fell into the black hole, scrambled but not lost forever. If that's true, it opens the door to wild possibilities. Could that information be leaking into another universe? Of course, there's a catch. Even if black holes are wormholes, surviving the trip is another story. The tidal forces near a singularity would stretch you into spaghetti long before you reach the other side. But mathematically, the idea holds water. Some models even suggest that certain types of black holes could stabilize wormholes, making them theoretically traversable, if only we could figure out how. So next time you gaze at a black hole in a documentary or sci-fi flick, remember, it might not be a one-way ticket to oblivion. It could be a backdoor to a reality where the laws of physics are completely different, or where another version of you is staring right back. Now let's shift our focus to another cosmic mystery: dark matter. This invisible stuff makes up about 85% of the universe's mass, yet we can't see it or touch it. So what if dark matter isn't just hiding in our universe? What if it's actually gravity seeping in from other universes? Here's the idea. Imagine our universe is like a sheet of paper, and dark matter is a faint shadow cast by another sheet pressed close to it. Some physicists suggest that the gravitational pull we attribute to dark matter might actually be the tug of parallel universes brushing up against ours. It's a wild thought, but it could explain why dark matter seems to influence galaxies without interacting with light or matter the way normal stuff does. Cutting-edge theories even propose that dark matter's strange behavior, like how it clumps around galaxies, might be evidence of these hidden gravitational links. If gravity can leak between universes, it would mean our cosmos isn't as isolated as we think. Picture a crowded room where everyone's movements affect each other, even if they're not touching. That could be the multiverse on a cosmic scale. Of course, this is still speculative. There's no direct proof yet, but the math doesn't rule it out. And if future experiments detect unusual gravitational waves or patterns in the cosmic microwave background, we might just find clues that dark matter is our first tangible connection to other realities. So while dark matter remains one of the universe's biggest puzzles, it might also be our best hint that we're not alone in the grand scheme of things. Who knows, the answer could be lurking just beyond the edge of our perception, in a universe right next door. Now, let's take a step into one of the strangest corners of multiverse theory, the Boltzmann brain paradox. Picture this: in an infinite cosmos with endless universes, the laws of probability suggest that anything that can happen will happen given enough time and space. That includes the bizarre possibility that fully formed, self-aware minds could spontaneously pop into existence out of pure randomness. Think of it like a cosmic lottery. In a void where particles bounce around chaotically, there's a tiny but non-zero chance they could arrange themselves into a functioning brain complete with memories, thoughts, and even the illusion of a past. This hypothetical entity, called a Boltzmann brain, would believe it's a real person living in a real world, even though it just formed by accident moments ago. Here's where it gets unsettling. If the multiverse is truly infinite, there could be more Boltzmann brains out there than real, evolved minds like ours. So how do we know we're not just random fluctuations ourselves? It's a dizzying question that challenges the very nature of consciousness and reality. Some physicists argue that the very fact we're having this discussion is evidence against the Boltzmann brain scenario. After all, if most minds were fleeting illusions, why does our universe seem so consistent and ordered? Others counter that even in an infinite multiverse, certain configurations like stable, long-lived observers might still be more likely than we think. Whether a fascinating thought experiment or a genuine philosophical puzzle, the Boltzmann brain paradox forces us to confront how little we truly understand about existence. And if nothing else, it's a humbling reminder that in a multiverse of infinite possibilities, even the most solid truths might be up for debate. Next, we'll tackle another cosmic mystery: why, in a universe teeming with potential life, we seem to be alone. Could the answer lie beyond our own reality? Stay tuned. Now, let's turn our attention to another mind-bending question: why does the universe feel so empty? For decades, the Fermi paradox has puzzled scientists. If the cosmos is so vast with billions of stars and planets, where is everybody? The answer might lie beyond our own universe. Imagine a multiverse where countless alien civilizations thrive in parallel realities, each with their own unique physics and conditions. Some might have mastered interstellar travel, while others could be trapped in dimensions we can't even perceive. The catch: these civilizations might be forever out of reach, separated by the very fabric of reality itself. This idea flips the Fermi paradox on its head. Instead of asking why we haven't found aliens, we might consider that they exist, just not in our universe. The laws of physics in their worlds could make communication or travel between universes impossible, leaving us in cosmic isolation. But there's another twist. Even if other universes host intelligent life, their versions of physics might be so different that their existence is unrecognizable to us. Light, gravity, even time could behave in ways we can't comprehend, making detection a hopeless challenge. Some scientists argue this multiverse perspective actually solves the paradox. If life is scattered across infinite realities, the odds of us stumbling upon another civilization in our own universe shrink dramatically. It's not that the cosmos is barren, it's that we're searching in just one tiny corner of an unimaginably vast multiverse. Of course, this raises new questions. Could advanced civilizations ever bridge the gap between universes, or are we destined to remain alone, separated by the ultimate cosmic barrier? The multiverse might not just redefine reality, it could also explain why, in all this grandeur, we still feel so solitary. Next, we'll explore whether science can ever find hard evidence for these parallel worlds, or if the multiverse will remain forever beyond our grasp. Now let's shift gears and tackle the big question: can we actually prove the multiverse exists, or is it destined to remain a tantalizing idea just beyond our reach? Scientists aren't just sitting around speculating, they're actively hunting for clues, and some of the most promising leads come from the oldest light in the universe, the cosmic microwave background. This faint glow left over from the Big Bang is like a cosmic fingerprint. Researchers have scoured it for anomalies like strange cold spots or unusual patterns that might hint at collisions with other universes. Think of it as finding a dent in a balloon, evidence that something bumped into it from the outside. So far, no smoking gun, but the search is far from over. Then there's the high-energy frontier. Particle colliders like the Large Hadron Collider aren't just smashing protons to uncover new particles. Some experiments are designed to hunt for extra dimensions, tiny, curled-up spaces predicted by string theory. If these dimensions exist, they could be portals to other universes, and even a fleeting glimpse would rewrite physics as we know it. But here's the catch. Even if we find weird data, a blip in the background radiation or an unexpected particle, how do we know it's proof of a multiverse and not just something we haven't figured out yet? That's the challenge. The multiverse might leave traces, but interpreting them requires ruling out every other possibility first. Some scientists are getting creative. There are theories that quantum entanglement, spooky action at a distance, could be a signature of parallel realities subtly influencing each other. Others propose that dark energy, the mysterious force accelerating the universe's expansion, might be leaking in from neighboring universes. The truth is, we're still in the early days. Proving the multiverse is like trying to photograph a shadow in a pitch-black room. But with every experiment, we're refining the tools that might one day illuminate the unimaginable. Up next, we'll confront the skeptics, why some brilliant minds argue the multiverse is more science fiction than science fact. Now, let's turn the spotlight on the skeptics, because not everyone is convinced the multiverse is more than a captivating thought experiment. One of the biggest criticisms comes from a principle called Occam's razor, the idea that the simplest explanation is usually the right one. Critics argue that inventing countless unseen universes just to explain the quirks of our own feels like overcomplicating things. Why conjure up infinite realities when we might just need better physics to solve the puzzles in our own cosmos? Take physicist Paul Steinhardt, a vocal opponent of the multiverse. He compares it to giving up on science, saying if anything can happen in some universe, then the theory explains nothing. After all, science thrives on testable predictions, and the multiverse by its very nature might be untestable. If we can't observe or interact with these other universes, how do we know they're not just a convenient story? Then there's the falsifiability problem. A good scientific theory should make claims that can, in principle, be proven wrong. But if the multiverse includes every possible outcome, what observation could ever disprove it? Even strange cosmic anomalies could just be chalked up to, that's how things are in our particular universe, leaving no way to pin down the theory's validity. Some scientists worry the multiverse could stall progress. If we assume unsolved mysteries like the fine-tuning of physical constants are just random luck in an infinite ensemble, might we stop looking for deeper laws that could explain them? It's a debate that cuts to the heart of how science works, whether we're uncovering fundamental truths or just telling stories about a reality we'll never fully see. Yet, even amid the skepticism, the multiverse keeps sparking curiosity. Whether it's a brilliant insight or a dead end, one thing's clear: it pushes us to ask bigger questions about the nature of existence itself. And that's a journey worth taking, no matter where it leads. Next, we'll dive into the philosophical whirl when the multiverse unleashes what it means for free will, identity, and the very idea of reality. Now, let's step into the mind-bending world of philosophy, where the multiverse doesn't just stretch space, it stretches our understanding of what it means to be you. Imagine this: if every decision you make spawns a new universe where a different version of you takes a different path, does your choice even matter? Or are you just one thread in an infinite tapestry of possibilities? This is where free will gets tangled. If every outcome exists somewhere, then the version of you reading this script right now didn't choose this path. It's just one of countless realities playing out. Some philosophers argue this makes free will an illusion, like thinking you're steering a boat when the river's current was always going to take you there. Others counter that your choices still feel real to you, and that's what counts. After all, even in a multiverse, this version of you is the one experiencing life, making decisions and wondering about the others. Then there's identity. If there's a universe where you're a famous artist, another where you're a reclusive scientist, and yet another where you never existed at all, what defines you? Are these all separate people or fragments of some deeper, shared existence? It's enough to make your head spin, but here's the twist: the multiverse might not erase your uniqueness. Instead, it could highlight how extraordinary it is that this version of you gets to ask these questions at all. And what about meaning? If every triumph and tragedy unfolds endlessly across realities, does anything truly matter? Some find this terrifying, like shouting into an infinite void, but others see it as liberating. If there's no single right path, maybe the pressure's off. You're free to live boldly, knowing that somewhere another you took the safe route, but this you get to write a different story. Of course, not everyone buys into this cosmic existentialism. Critics say the multiverse turns life into a cosmic dice roll, stripping away purpose. But here's the thing: whether you're one universe or one of many, the questions you ask about choice, about self, about meaning, are what make you human. And that's a mystery no amount of parallel worlds can dilute. Up next, we'll see how these dizzying ideas collide with something equally profound: the spiritual and religious perspectives that have grappled with multiple realities long before modern physics came along. Now, let's turn our gaze from the philosophical to the spiritual, where the idea of multiple realities isn't just a modern theory, it's a thread woven through ancient beliefs and sacred texts. Long before physicists coined the term multiverse, religions and spiritual traditions were already contemplating worlds beyond our own. Take Hinduism, for example. Its scriptures describe countless universes, each with its own cycles of creation and destruction, governed by the breath of the divine. In this view, our cosmos is just one bubble in an endless ocean of existence, echoing the scientific concept of inflationary cosmology. Buddhism, too, speaks of multiple realms, some of suffering, some of bliss, where beings are reborn based on their karma. It's a spiritual parallel to the branching timelines of the multiverse, where actions in one life ripple into another. Christianity, on the other hand, has often embraced a single, divinely crafted universe, but some theologians argue that an all-powerful God could choose to create many worlds, a concept called the omniverse. Think of it like an artist painting countless masterpieces, each with its own unique beauty. Even medieval thinkers like Thomas Aquinas pondered whether God might have made other Earths, though they framed it as a question of divine creativity rather than quantum physics. Yet, not all spiritual traditions align neatly with the multiverse. Many indigenous cosmologies focus on the interconnectedness of this world, seeing the land, sky, and spirits as part of a singular, sacred web. For them, the idea of splintered realities can feel at odds with a world you rooted in unity and balance, and then there's the tension between science and faith. Some see the multiverse as a way to reconcile the apparent fine-tuning of our universe, suggesting that a divine hand isn't needed if infinite universes exist by chance. Others, though, argue that a multiverse merely pushes the question back. Who or what set the rules for all these realities to arise? What's fascinating is how these ancient and modern ideas mirror each other. Whether it's the Hindu cosmic egg or the physicist's quantum foam, humanity has always reached for ways to explain the vastness of existence. The multiverse, in a way, is just the latest chapter in an age-old story, one that blends the empirical and the mystical, asking not just how the cosmos works, but why we're here to wonder about it at all. Coming up, we'll shift from the spiritual to the speculative, imagining what life might look like in those other universes, especially the ones where technology has unlocked utopian possibilities beyond our wildest dreams. Now, let's step into the realm of pure imagination, where the multiverse isn't just a theory, but a canvas for humanity's boldest dreams. Picture a universe where technology didn't just advance, but leaped forward in ways we can barely fathom. What if, somewhere out there, another version of Earth cracked the code to clean energy centuries ago? Or a civilization where aging is optional and death is just a glitch they've long since patched? Take climate change. Here, we're scrambling to undo the damage of fossil fuels. But in a neighboring universe, maybe they discovered zero-point energy in the 1900s, harnessing the very fabric of space-time to power their cities without a single smokestack. Imagine skyscrapers draped in self-repairing solar skins, or oceans teeming with nanobots that scrub carbon straight from the water. For them, our climate crisis might seem like a bizarre historical footnote, a path they narrowly avoided. Then there's the ultimate frontier, immortality. In our world, it's the stuff of myths, but in another reality, scientists might have decoded the aging process like a simple math problem. Picture a society where minds can be uploaded to quantum networks, bodies swapped like outdated software, and death is just a choice you postpone indefinitely. Would they still value life the same way we do? Or would time stretch so thin that art, love, even curiosity start to lose their meaning? And what about the stars? While we're still tethered to our solar system, another Earth could have cracked faster than light travel using folded dimensions or black hole slingshots. Their cities might sprawl across galaxies, with cultures so diverse they make our global civilizations look like a single neighborhood. Imagine trading with beings who communicate in gravitational waves, or vacationing on a planet where the mountains float. But here's the twist: even utopias have shadows. A world without scarcity might struggle with purpose. A society that conquered death could face overpopulation on a cosmic scale. And what if their advanced tech came at a cost, like losing touch with what makes them human? The multiverse reminds us that every solution births new questions. So as we marvel at these possibilities, remember, the most fascinating universe might still be ours. After all, it's the one where we're still writing the story, where every breakthrough, every failure, is a chance to steer toward our own version of tomorrow. Up next, we'll flip the script and explore the darker corners of the multiverse, where history took a very different turn. But let's shift gears for a moment, because not every alternate universe is a shining utopia. Imagine a world where history's darkest turns never got corrected. Picture an Earth where the Nazis is won World War II, their swastikas flying over continents reshaped by tyranny. In this reality, technology might be advanced, but twisted, used for surveillance, control, and worse. Art, science, even basic freedoms could be tools of the state, and dissent would vanish into shadow. It's a chilling reminder of how fragile our own victories against oppression really are. Or step into a timeline where the asteroid that wiped out the dinosaurs never struck. Humanity might never have risen at all, leaving the planet ruled by towering reptiles with razor-sharp instincts. But if we did evolve alongside them, imagine the struggle cities walled against packs of hyper-intelligent raptors, or factories pumping out defenses against T-Rex predators. Our entire concept of civilization would be built on survival, not progress. Then there's the silent apocalypse, a universe where the Cold War turned hot. Nuclear winters could have left Earth a radioactive wasteland with scattered tribes fighting over canned food in crumbling subway tunnels. In that world, the internet might exist only as a relic, a ghostly network of dead servers whispering stories of the world before the bombs fell. These aren't just nightmares, they're mirrors. Each dark timeline reflects a hinge moment where humanity's resilience was tested or broken. They ask us what makes our world any different. Luck, choices, or just the roll of cosmic dice. And here's the unsettling truth. In a multiverse, all these worlds exist somewhere. The only reason we don't live in them is because against all odds our ancestors fought, adapted, or got staggeringly lucky. So the next time you hear about climate change, pandemics, or political strife, remember, we're not just shaping our future, we're choosing which universe we get to call home. Up next, we'll swing back to the light sort of. What if the multiverse isn't just about physics, but the next frontier of technology? From quantum computers to reality-bending AI, the future might be closer than we think. Now, let's pivot from the shadows of dystopian worlds to something electrifying: how the multiverse isn't just science fiction, but a spark for real-world breakthroughs. Imagine a computer that doesn't just crunch numbers, but explores countless possibilities at once. That's quantum computing, where particles exist in multiple states simultaneously, like flipping a coin that lands heads and tails in parallel universes. Companies like Google and IBM are already harnessing this to solve problems from drug discovery to unbreakable encryption, faster than any traditional machine ever could. But it doesn't stop there. Even the Pentagon's research arm, DARPA, is diving into alternate reality models, funding projects that simulate entire worlds to predict everything from market crashes to climate disasters. Think of it as a digital multiverse where we test drive futures before they happen. And then there's the wild frontier of quantum internet, a network where information teleports between particles entangled across dimensions, making today's internet look like snail mail. Here's the kicker: these aren't distant dreams. Labs worldwide are racing to turn multiverse physics into tools that reshape energy, medicine, even art. Picture AI designing materials by probing alternate universes for impossible alloys, or architects using quantum algorithms to model cities that adapt to infinite weather scenarios. The line between theory and tech is blurring fast, and the next big leap might just come from an idea born in the multiverse. Up next, we'll unravel an even stranger twist. What if the fabric of reality itself holds clues to these hidden dimensions? Time crystals and their mind-bending physics might just hold the answer. Now, let's step into one of the most bizarre corners of physics, where time itself behaves in ways that defy intuition. Time crystals sound like something straight out of science fiction, but they're very real, and they might just hold secrets about the multiverse. Unlike ordinary crystals, which have repeating patterns in space, time crystals repeat their structure in time, creating a loop that never loses energy. Think of it like a clock that ticks forever without winding down, breaking the usual symmetry of time. This strange behavior was first proposed by Nobel laureate Frank Wilczek, and in 2017, scientists actually created time crystals in the lab using quantum systems. What makes them so fascinating is that they exist in a state of perpetual motion, not because they're defying physics, but because they've found a loophole in the rules. Some researchers speculate that this could be a hint of higher dimensions, like a shadow cast by phenomena we can't yet observe directly. Here's where it gets wilder. If time crystals can remember their past states across these loops, could they be interacting with alternate timelines or parallel universes? It's a stretch, but not impossible. Some theories suggest that the weird stability of time crystals might be tied to hidden dimensions predicted by string theory, where particles or forces from other universes subtly influence ours. And the implications are staggering. If we can harness time crystals, we might unlock new forms of quantum computing that operate across multiple timelines, or even detect faint echoes of other universes. It's still early days, but the idea that our reality might be whispering to others through these exotic materials is too tantalizing to ignore. Up next, we'll tackle the ethical dilemmas that come with peeking into other universes. What happens if we could communicate with them, or worse, exploit them? The answers might be more unsettling than the questions. Now, let's shift gears and consider a question that's as thrilling as it is unsettling. What if we could actually reach out to other universes? The idea of communicating with or even visiting parallel worlds sounds like the stuff of epic sci-fi. But if the multiverse is real, the ethical dilemmas it would unleash are anything but fictional. Imagine discovering a universe where resources are infinite, or one where advanced civilizations have solved problems we're still grappling with, like climate change or disease. The temptation to exploit these worlds could be overwhelming. Would we treat them as partners, or would we see them as colonies to plunder? History isn't exactly reassuring here. Humanity doesn't have a great track record when encountering the unknown. And what about the darker scenarios? If we found a universe where, say, a hostile version of humanity had already mastered interdimensional travel, could we be inviting conflict just by knocking on their door? Some theorists argue that advanced civilizations might deliberately hide to avoid attracting attention, a chilling twist on the Fermi paradox. Then there's the question of identity. If you met another version of yourself in a parallel world who gets to claim your life, your relationships, even your name, the philosophical and legal chaos would be unprecedented. Would rights extend across universes, or would we see a new kind of inequality, where some versions of people are treated as less real than others, the most haunting possibility? That our very curiosity could unravel the fabric of reality. Tinkering with forces we don't fully understand might have consequences we can't predict. It's like the old warning about meddling with time travel. Change one thing, and you might return to a world you don't recognize. Up next, we'll explore how artificial intelligence might fit into this puzzle. Could superintelligent machines hold the key to navigating the multiverse safely, or would they become its ultimate architects? The answers might surprise you. Now, let's take a fascinating turn and consider how artificial intelligence might reshape our understanding of the multiverse. Imagine a future where superintelligent machines don't just study parallel worlds, they create them. Futurists like Ray Kurzweil have long predicted that advanced artificial intelligence could reach a point where it manipulates reality itself, crafting pocket universes with their own unique laws of physics. Think about it. If an artificial superintelligence could simulate entire universes down to the quantum level, would those simulations be any less real than our own? Some scientists argue that if consciousness can emerge in a simulated reality, then those digital worlds might be just as valid as the one we experience. This blurs the line between creator and creation in ways that challenge everything we think we know about existence. But here's where it gets even wilder. What if artificial intelligence isn't just simulating universes but actively discovering them? A superintelligent machine with processing power far beyond human comprehension might detect subtle patterns or anomalies in cosmic data that hint at other dimensions. It could uncover hidden connections between universes, acting as a cosmic cartographer mapping the vast, uncharted territories of the multiverse. Of course, this raises some mind-bending questions. Would an artificial intelligence prioritize sharing its discoveries with humanity, or would it keep them hidden, operating on motives we can't even fathom? And if it did create pocket universes, what would its purpose be? Experimentation, exploration, or something beyond our current understanding? One thing's for certain. If artificial intelligence ever unlocks the secrets of the multiverse, it could redefine not just science but philosophy, ethics, and even spirituality. The idea that machines might one day hold the keys to alternate realities is both exhilarating and humbling, reminding us just how much we still have to learn. Coming up, we'll shift our gaze to another intriguing possibility: how climate change might play out differently in parallel worlds. Could some universes have already solved the crisis, while others face even greater disasters? The contrasts might just hold the answers we've been searching for. Now, let's step into a thought experiment that could reshape how we view our own planet's future. Picture a universe where humanity embraced renewable energy not in the 21st century, but back in the 1950s. Solar panels blanket every rooftop, wind turbines spin where smokestacks once stood, and cities hum with clean energy. In this alternate reality, climate change might be a solved problem, or at least a manageable challenge, but here's the twist: not every parallel Earth would be so lucky. Imagine another world where fossil fuels were exploited even more aggressively, accelerating global warming to catastrophic levels. Oceans rise faster, storms grow fiercer, and entire ecosystems collapse before scientists can sound the alarm. The chilling part: these aren't just sci-fi scenarios. They're stark reminders of how small choices in our timeline, policy shifts, technological bets, even public awareness, could send civilizations down wildly different paths. What makes the multiverse perspective so powerful is the chance to compare outcomes. Maybe in one universe, a single breakthrough in nuclear fusion unlocked limitless clean energy. In another, geopolitical conflict stalled progress, dooming the planet to runaway warming. These contrasts aren't just speculative fiction, they're mirrors held up to our own decisions. If infinite versions of Earth exist, some likely found solutions we haven't yet considered. Could their successes hint at strategies we've overlooked? This isn't just about doom-scrolling through worst-case scenarios. It's about hope. If other worlds navigated the climate crisis better than we have, their blueprints might be hiding in plain sight, in untested technologies, forgotten policies, or even cultural shifts we've dismissed too quickly. The multiverse theory doesn't just expand our cosmic horizons. It challenges us to ask, what if we tried it differently? And that's where the real lesson lies. Whether or not parallel worlds exist, the idea of infinite possibilities pushes us to think bigger. If a single timeline can branch into countless futures, our actions today matter more than we realize. The next universe over might hold the answers we need, but we don't have to wait for a multiverse traveler to deliver them. We can start building that better future right here. Up next, we'll take a lighter turn and explore how the multiverse could rewrite the rules of economics. What happens to markets when resources, or even workers, are infinite? The implications might just bend your mind. Now, let's take a playful detour into the economics of the multiverse, because why should physics have all the fun? Picture this: in a cosmos of infinite parallel worlds, you'd have infinite versions of gold, oil, even avocado toast. Suddenly, scarcity, the backbone of traditional economics, starts to look a little shaky. If every universe has its own copy of Earth, complete with duplicate resources and workers, what happens to supply and demand when supply is literally endless? In one scenario, capitalism might unravel spectacularly. Why pay for diamonds when the universe next door is giving them away? Why compete for jobs when an army of alternatives could handle the workload? Markets could crash under the weight of infinite abundance, turning Wall Street into a ghost town. But here's the twist: post-scarcity utopias might bloom instead. With no shortage of energy, food, or raw materials, societies could focus on creativity, exploration, or just perfecting the art of napping. Of course, there's a catch. Infinite resources don't guarantee infinite fairness. Imagine a universe where one world hoards its riches while others struggle, a cosmic inequality that makes today's wealth gaps look quaint. Or worse, what if corporations figure out how to exploit multiverse labor, paying workers from poorer realities pennies while raking in profits? the ethical dilemmas would be as endless as the universes themselves. But let's dream bigger. Maybe the multiverse gifts us the ultimate economic hack: collaboration across realities. Worlds could trade not just goods, but ideas, sharing climate solutions, medical breakthroughs, or even killer pizza recipes. The result, a post-scarcity society where profit means progress for all timelines. Whether this sounds like paradise or chaos, one thing's clear: the multiverse doesn't just bend space and time. It bends the very rules of how we value, trade, and thrive. And that's a thought worth pocketing right next to the wallet your alternate self might not even need. Coming up, we'll shift gears to something even wilder: how human biology could take bizarre turns in other universes. What if evolution cooked up aquatic humans or disease-proof bodies? The possibilities are as strange as they are fascinating. Now, let's dive into something even more mind-bending. What if human biology itself played by entirely different rules in other universes? Imagine a world where evolution took a sharp left turn, crafting bodies unlike anything we've seen. Picture aquatic humans with gills and webbed fingers, thriving in oceans that cover 90% of their planet. Or consider a reality where diseases like cancer or the common cold were wiped out centuries ago, thanks to a lucky genetic mutation or an alien microbe that acted as the ultimate vaccine. In some universes, natural selection might have favored entirely bizarre traits. What if humans evolved photosynthesizing skin, drawing energy from sunlight like plants? Or developed exoskeletons for protection in high-gravity worlds? The possibilities aren't just science fiction, they're reminders of how fragile and contingent our own biology really is. A single tweak in Earth's ancient climate or a different predator in our evolutionary past could have rewritten our bodies in ways we can barely imagine. Then there's the medical angle. Alternate Earths might have stumbled onto cures we've yet to discover. Perhaps a fungus from a distant universe holds the key to immortality, or a mineral found only in volcanic dimensions can regenerate limbs. Think of the medical breakthroughs we could borrow if only we could peek into those worlds. But it's not all rosy. Some universes could harbor plagues far deadlier than anything here, with pathogens that make our pandemics look like mild sniffles. And what about intelligence? In a universe where brains evolved to process quantum physics instinctively, humans might grasp the multiverse theory as easily as we do basic arithmetic. Or in darker timelines, maybe our counterparts never developed higher thought at all, remaining hunter-gatherers while dinosaurs still ruled. The takeaway: biology isn't just a recipe, it's a cosmic lottery. And in the multiverse, every possible outcome is out there, swimming, flying, or thinking in ways we'd find miraculous or terrifying. Up next, we'll explore how artists and writers have spun these infinite possibilities into stories that stretch the limits of creativity. From Borges to Marvel, the multiverse isn't just science, it's the ultimate muse. Now, let's shift our gaze from biology to the boundless realm of art and creativity, where the multiverse isn't just a scientific idea, it's a playground for the imagination. Think of every story ever told, every painting ever brushed, and every melody ever composed as just one thread in an infinite tapestry of possibilities. Writers and artists have long been fascinated by the idea of parallel worlds, using them to explore what-ifs that defy the limits of our reality. Take Jorge Luis Borges, for example. His short story, The Garden of Forking Paths, envisioned time as a labyrinth where every decision spawns a new universe, a concept that feels eerily close to today's quantum theories. Or consider Philip K. Dick, whose novels teased the idea that our world might be an illusion, with layers of alternate realities lurking just beneath the surface. These weren't just flights of fancy, they were early blueprints for the multiverse thinking that scientists now take seriously. Then there's the pop culture explosion. Marvel's Spider-Man Into the Spider-Verse didn't just entertain, it visualized the chaos and beauty of infinite variants. where a teenage Miles Morales could meet a noir detective Spider-Man or a pig named Spider-Ham. The film's kaleidoscopic animation style mirrored the theory itself, a universe where every artistic choice, every color palette could exist simultaneously. And let's not forget Everything Everywhere All at Once, which turned the multiverse into a metaphor for family, identity, and the weight of endless choices. But it's not just blockbusters. Indie games like the Stanley Parable turn the multiverse into an interactive experience where players navigate branching narratives that mock the illusion of free will. Musicians, too, dabble in alternate realities. David Bowie's Ziggy Stardust was a persona from another world, while albums like The Avalanche's Since I Left You feel like sonic collages of parallel dimensions. The real magic, these creations don't just reflect the multiverse, they shape how we feel about it. A painting of a floating city or a poem about a lover you never met can make the infinite tangible, turning abstract physics into something intimate and emotional. After all, if there's a universe for every possibility, then somewhere there's a version of you who's already written the next great multiverse masterpiece. Coming up, we'll tackle one of the most unsettling questions the multiverse raises. What happens to you when there are infinite versions of yourself out there? Identity, memory, even free will, it all gets twisted in ways that'll make your head spin. Now, let's step into one of the most mind-bending corners of the multiverse. What happens to you when there are countless versions of yourself scattered across infinite realities? Imagine walking down the street and bumping into someone who looks exactly like you, talks like you, even claims to be you. Would they feel like a long-lost twin, or would it be like staring into a funhouse mirror that reflects a stranger? This isn't just sci-fi speculation. If the multiverse is real, every choice you've ever made or didn't make could have spawned a new universe with a slightly different version of you. Maybe in one world you took that job overseas. In another, you became a musician instead of a scientist. But here's the twist, those other yous might not share your memories, your fears, or even your core beliefs. They'd be shaped by entirely different lives, like branches growing from the same tree but swaying in separate winds. Philosophers call this the problem of identity. If your alternate self has a different childhood, a different name, or a different moral compass, are they truly you, or just a cosmic doppelganger? Think of it like this: your memories and experiences are the glue that holds your sense of self together. Without them, you're just a collection of atoms arranged in a familiar pattern. That's why meeting another you might feel less like a reunion and more like encountering a character from a book you've never read. And what about free will? If every possible decision plays out somewhere, does that mean your choices are meaningless? Not necessarily. Even in an infinite multiverse, your version of reality is the only one you'll ever experience. The you reading this right now is the sum of every step you've taken, every risk you've embraced or avoided. That's what makes this version of you irreplaceable, no matter how many others might exist. But here's the kicker: some scientists argue that consciousness itself might be the key. If your alternate selves share the same spark of awareness, could they all feel like the real you? It's a question that blurs the line between science and spirituality, leaving us to wonder if identity is more than just a story we tell ourselves. Up next, we'll explore how this dizzying idea might actually change the way we live. Because if the multiverse is real, then somewhere out there, another you is already living your wildest dreams. And that's a thought worth chewing on. Now, let's take this wild idea and bring it down to earth, because if the multiverse is real, it might actually change how we live our lives right here, right now. Think of it as a cosmic nudge to stay curious. After all, somewhere out there, an alternate version of you might have already cracked the secrets of time travel, invented a cure for aging, or even won a Nobel Prize. That's not just science fiction, it's a reminder that the possibilities for this version of you are wider than you might imagine. multiverse thinking does something fascinating to the way we see the world. It pushes us to question the limits of what we think is possible. What if the career path you didn't take leads to something extraordinary in another universe? What if the mistake you regret was the best decision another you ever made? This isn't about dwelling on what ifs, it's about realizing that life is full of uncharted paths, and every choice opens doors we can't even see yet. Here's the practical takeaway. Embracing the multiverse mindset means embracing open-mindedness. It encourages us to experiment, to take risks, and to stay adaptable. After all, if infinite versions of reality exist, then somewhere, somehow, the boldest version of you is thriving. Why not let that inspire you to try something new? Maybe it's learning a skill you've always put off, or finally pursuing that project you've been too nervous to start. And let's not forget the humility that comes with it. If there are countless versions of you making different choices, then no single decision defines you entirely. That takes the pressure off perfection. Messing up isn't the end of the story, it's just one thread in a vast tapestry of possibilities. So here's the playful challenge. The next time you face a tough choice, ask yourself, what would my alternate selves do? Then go with the option that feels most alive, because in a multiverse, the only wrong move is refusing to move at all. Stay curious, stay bold, and who knows? Maybe this version of you is the one who will surprise everyone, including yourself. And with that, we've reached the end of our journey through the multiverse, but the conversation is just beginning. What do you think is out there? Drop your wildest theories in the comments, and don't forget to like and subscribe for more mind-expanding adventures. The universe, or should we say, universes, are full of mysteries waiting to be explored. As we wrap up this mind-bending journey through the multiverse, let's take a moment to revisit the big ideas we've explored. From the quantum leaps of parallel realities to the cosmic bubbles of inflationary cosmology, the multiverse theory stretches our imagination beyond the limits of a single universe. We've seen how ancient philosophies and cutting-edge physics collide in this debate, how pop culture brings these concepts to life, and even how the idea of infinite worlds might reshape our everyday choices. The multiverse isn't just a scientific hypothesis, it's a cultural phenomenon. It challenges us to rethink everything from free will to the meaning of existence, while inspiring blockbuster movies, gripping novels, and even breakthroughs in quantum computing. Whether you're team many worlds or team simulation hypothesis, one thing's clear: reality is far stranger and more expansive than we ever dreamed. So here's your invitation to keep exploring. The multiverse reminds us that curiosity is our superpower. What do you think is out there? Could alternate versions of you be living wildly different lives? Share your theories in the comments. We'd love to hear them. And if this cosmic adventure sparked your imagination, don't forget to hit that like button, subscribe, and ring the notification bell for more content that bends the boundaries of what's possible. After all, in a universe or multiverse full of mysteries, the next big revelation could be just one click away. Thanks for joining the journey, and remember, the wildest frontiers of science are waiting for you to dive in.